All right. So, welcome everyone. So, today we are going to have the first lecture on science and technology. So, we are starting the module of science and technology in GS Foundation batch. Already, let's say some subjects have been covered, but we are starting afresh with science and technology today. And today our goal of understanding will be like we are going to cover unit 1 of science and technology, where we will understand about physics, astrophysics, space science, astronomy related topics. And UPSC has asked many questions from this area in the past, right? So today we are going to understand some concepts related to this. We will look into the previous year questions, and also we will see the weightage of science and technology in prelims and as well as in mains, right? So in prelims around 10 to 15 questions are asked by UPSC every year, means there is a weightage of about 20 to 30 marks, right, in prelims exam. In mains exam, they ask, let's say, about 3 to 4 questions, which is equivalent to 35 to 50 marks in the mains exam, right, out of 250. So around 20% weightage is there in GS paper 3 in science and technology. So like today we want to understand science and technology. We want to start our journey in science and technology. So here we need to understand about this thing, like, in science and technology, basically today we are going to discuss about a concept, and these concepts need let's say an understanding which is, let's say, over and above what science and technology teaches us. So for that I will take you through a story. I'll talk about a story. Then after this story I'll let's say make you understand about one concept, right? So first of all, write the quotation, which is, it says, it is impossible to account for the creation of the universe without the agency of the supreme being. So long back, the politicians, right, in different countries, they used to make census, right, when they used to speak, right, so like this is the thing. So this is one of the quotation that I really find to be so much senseful. So he says that, if you want to account, if you want to know that how the universe was created, right, so without the agency, without knowing that there is some role of the God, right, we cannot account that the universe was created. So there is definitely some role of the God. This is what is being, let's say, said through this particular quotation. And to understand this particular thing, I'll talk about a story. So let's understand a very important and very good story. And so this story starts with one thing. So there was a person, long back, there was a person, and that person used to come from Persia. Persia is the name of a country that we presently know as Iran. So from Persia, he happened to come to Surat in India. So that person was a theologian. Theologian means a person who, let's say, studies about religion, who, let's say, studies about religion, who talks about religion, who writes about religion. So he was a very, very much a scholar person, right? And the thing is, he has studied about religion so much that he got confused with many things related to religion. So what has happened, he ultimately, after reading so much, right, he himself got confused whether God really exists or not, right, after spending his lifetime into this. So the thing is, once he visited Surat, so he went to a coffee shop, right, this is known as the coffee house of Surat. So there, let's say, he had a servant also with him. So long back, there used to be people who were bonded laborers. So he had a servant with him. So he kept the servant outside and he went inside the coffee shop. So he, let's say, ordered something from the coffee shop, which was a drink of opium. So after drinking this, again, this thought came to his mind, right, whether God exists or not. So what he asked to his servant who was sitting outside the coffee shop that, do you think that the God exists? What the servant replied, so that servant had a piece of, let's say, piece of something idol, something made up of idol. So he brought out of his pocket, he said, yes, God exists, and this is how God looks like, right? So he started this way. But inside the coffee shop, there were many people. There was a person who came from Israel, right? So that person who came from Israel, he said that this is not the true form of God that you are showing. What he says, that the true form of God is what we worship in Israel, what Israelites worship. And so God is testing us. That's why God has sent us all across the world to check our perseverance, to check our understanding. So he said this thing. So he praised about, let's say, like, the kind of religion that they practice in Israel. Then to oppose him, there was another person, right? A Brahmin person. He said, like, whatever you are saying, it is rubbish. The Brahmin person said, whatever you are saying is rubbish. And he said that, like, true God is worshipped in India, right? Only the Brahman people who follow Brahminical religion, they are the ones who are true worshippers of God. And the universe was created by Lord Brahma. Brahma is the creator of the universe, he said. And so, like, on the river Ganges, and also, like, there reside some Brahmin people, and they have been worshipping Brahma from ages. He said, like, only, like, God, universe was created by Brahma, and he is the ultimate God. To oppose him, some other person came. So the discussion that was happening among these people, it got heated. And there was one person who was staying silent. He was, let's say, like, sitting somewhere in the corner, because he did not want to participate in the kind of discussion that the people were having. So, like, all these people were disagreeing with one another. Those people who, let's say, started into the discussion. A person who came from Persia, a person from Israel, a person who follows Brahminism. There was a person who follows Islam also. So, like, there was disagreement among them. The person who was sitting near this, so that person was from China, right? So that person, let's say, followed Confucius. So they asked, tell me, like, whether I am saying right, or he is saying right, or he is saying right. So what he said, so, like, he did not give the right answer, direct answer to them. He said that, like, I am going to narrate a story, and through that story you will get to know that, like, who is the true creator of the universe, who is the true God. So what he said that, like, I am a person who has traveled across the world through the oceans, right? And so I have, let's say, traveled on the steamship that was made by the Englishman. So I traveled on it, and I have seen, let's say, I went to a place, there was a person, and that person was a blind person. And why that person became blind? Because, like, he continuously looked at the sun. He used to see the sun for a very long period of time to understand what is sun, what is the nature of the sun. To understand that particular thing, he used to continuously see, but somehow he got blind because of the sun rays falling on his eyes for a long period of time. So the thing is, like, the person who got blind by seeing the sun for a long period of time, like, he came up with an idea that sun is not a water, it's not liquid. Why? If it would have been liquid, so it will spill over. It's not a fire also. He said it's not a fire. Because if it would have been a fire, so the thing is, like, the water might have, let's say, extinguished it. So he came up with a lot of ideas of himself, right? Again, let's say he had, let's say, a person who was his, servant. He asked him. So that servant said that, like, even I don't have any idea about the sun, but the thing is, like, I have a match, I have a candlestick using which I can, let's say, lighten up the room. For me, this is the sun. He said this thing. But the thing is, like, there were many people in the ship, like, the Confucius people, the person who followed Confucius, he said that in the ship where we traveled, so a lot of people were there from different nationalities. They had a heated debate that, like, where the sun rises, where it, let's say, like, sets. So some people said that it rises in the ocean, it, let's say, like, ultimately sets in the ocean. Some people said it rises in the mountains and it ends in the mountain. So long back there used to be this kind of debate because people did not know the true reality, right? So, like, that particular heated debate, ultimately it resolved into this matter that, like, sun does not rise near the mountains or near this thing. So sun is available to many planets like us. So it is available to our planet, and our planet is revolving around the sun. And later on, long back, there was a philosopher. What was his name? The name of the, like, there was a philosopher who was hanged till death. Like, he said that the earth is round, Like, earlier, people used to consider that earth is flat, right? People used to consider earth is flat. But later on, he said, I think Plato or Aristotle, you need to see yourself, right? So he said that the earth is round, and like people did not believe in him, right? Later on, after he died, after he passed away, long back, people got to know that like he was saying right, okay? So the thing is, after narrating this particular story, he said that like, God is something on which you have your faith, right? He can be worshipped in different forms, right? You can worship him, Aristotle, right? So you can worship him, right, in any manner that is there, but the true form of God may not be residing in the kind of, let's say, like, in the kind of structures that you are building, right? For God, there is vast majority thing. For him, the lighting source can be the sun. For him, the, let's say, like, source of water can be the oceans, like that. He said this particular thing. So after understanding this story, right, after understanding this story, what we get to know? We get to know that, like, people perceive different things based on their experiences, based on their value system, based on their, what they have learned, right? But the thing is, all the value system, all the things that we have learned, it is, let's say, like, narrow to the extent that we know the things. Are you understanding? Means like it is like somewhat narrow to the extent that we understand. The more we keep inquiring about the things, the more we will be learning about the things, right? And this story that I have narrated this, right? So ultimately, let's say after hearing whatever the Chinese person said, all the other persons were satisfied, right? They were satisfied and they did not further do this thing. So the thing is, after understanding this story, what we understand is that, like, everybody perceives that the world was created in a different manner. For a person who follows Hinduism, for him, let's say, like, his religion, his, let's say, ideology has taught him that this is the way how the universe was created. For a person who comes from Israel, it may be a different notion altogether. For a person who comes from different part of the world, his notion, his religion might have taught him that this way the world was formed, the universe was formed. Similarly, there is a narrative from the scientific community also. There is a narrative from the scientific community. And so far, the scientific community has come up with a lot of evidence also, how the universe was created, right? They have come up with a lot of evidence how the universe was created. So as of now, we do have different theories about creation of the universe. Some theories have given many, let's say, like, experimental proof also that this is how universe might have been created. But still, today, if we talk about how the universe was created, there is no single idea that dominates all over the world, right? Somewhere something is lacking, but research is going on. So today we are going to talk about, let's say, one important thing, that how the universe was created. What? How the universe was created. And this story that I have narrated to you, this story is known as the coffee house at Surat. What? This story is known as the coffee house at Surat. And this story has been written by a person whose name is Leo Tolstoy. Who? Leo Tolstoy. So Leo Tolstoy is a person who was an author. He was a thinker, and he lived, like, in the 19th and 20th century. So he is a person, let's say, like, he has met with kind of, let's say, he felt that, like, there was intellectual void in his life. So at the age of 70, and let's say, like, he has written so many things, right? And one of the, let's say, book that he has written, he said, the world of God lives within you. He has said, the world of God lives within you. And Leo Tolstoy is a, let's say, Russian, he is a Russian writer, right? He is a Russian writer. So, I mean, like, Russian writer, thinker, he has been nominated for Nobel Prize in Literature from 1902 to 1906, 1902, 1903, 1904, 1905, 1906. And he was also nominated for Nobel Peace Prize for many years, right? He was nominated for all of these things. The story that I have narrated, it is a story that has been told by Leo Tolstoy. So now, having understood this story, the coffee house at Surat, right, we will understand about a theory which is known as Big Bang theory. We will understand about various other theories also that people have narrated related to how the universe was formed, right? So, like, let us understand this question, that how the universe was formed. And before this, let me write down another quotation. This quotation you have written. So, the way how we are going to understand this subject is, we are going to understand this subject from an interdisciplinary manner. We will understand about science, major part will be science, but like, we will understand in a manner so that you can relate this thing with the outer world. So far we have been reading science and technology in school, in colleges, but somehow, let's say, it was a kind of learning in silos. We were learning in, let's say, in isolation with other subjects. If we learn in isolation, we are not able to apply that thing in real life. We are not able to connect it with other events that are happening. But like, our point of understanding will be to cover the UPSC syllabus, and at the same time, we are going to understand in a manner so that you can relate it with the real life, okay? So now, let me write down another quotation. This quotation is from a very, let's say, like, renowned scientist, right? So this quotation, it says, the deep emotional conviction of the presence of a superior reasoning power which is revealed in the incomprehensible universe. Which is revealed in the incomprehensible universe, forms my idea of God. What? Forms my idea of God. So this has been said by Albert Einstein. Good afternoon, Vidya. Thank you so much for joining. So, Albert Einstein says that the deep emotional conviction of the presence of a superior reasoning power, which is revealed in the incomprehensible universe, forms my idea of God. What he says, even Albert Einstein says that the universe that is existing, right, the universe that is there, this universe is so powerful, it does have a, let's say, reasoning in itself, which is incomprehensible to us, which is incomprehensible to human beings. So this forms my idea of God. So he says that, like, since we are not able to understand the supreme reasoning power, so that's why we are reasoning it to God, that's why God exists. Okay, that's why he said. And Albert Einstein has given a lot of important theories, he has given a lot of important things that we are going to discuss, and like, he has also helped us to shape our understanding about the universe, right? To shape our understanding about the universe. This is the thing. So have you written this quote? You can write down these quotation in your, let's say, like, answers while you write essays, right, on science and technology, while you write answers on ethics papers, while you write answers somewhere, right? If you use this quotation, your answer stands out, right? This is the thing. And apart from this, I will talk about another, let's say, like, another important quotation that has been talked by very important person. So he talks about, let's say he talks about, since like Albert Einstein has talked about special theory of relativity, general theory of relativity. In the last demo class that we had, we discussed about, let's say, theory of relativity. We discussed about, let's say, how he shaped our understanding that something like gravitational waves exist, right? He talked about time dilation. He talked about length contraction. So long back we had a discussion, so it was an open session, right? So there we discussed about it, right? So that's why we are writing about Albert Einstein. And so, like, today itself we are going to understand about black holes as well. So related to black holes, there was a scientist who has done enormous amount of work. Have you heard about the name of Stephen Hawking? Stephen Hawking. So basically when you read about black holes, you will come across this particular thing which is known as Hawking radiation. We'll learn about this, right? So Stephen Hawking also has played role in shaping our understanding about black holes. We will understand what is the role of black hole in the overall composition of the universe, right? So related to Hawking, Stephen Hawking, we are going to write down another quotation. Okay, let me make it little bigger so that like those people who are not able to see it, right? So they will be able to understand. So this is going to be very important. Write down this thing, because there is a law such as gravity. Because there is a law such as gravity. Because there is a law such as gravity, the universe can and will create itself. The universe can and will create itself. From nothing. From nothing. Full stop. Now write down. Spontaneous creation is the reason spontaneous creation is the reason. Spontaneous creation is the reason there is something rather than nothing. There is something rather than nothing. Why the universe exists, why we exist. This has been said by Stephen Hawking. Write it down. I am reading it for you again. Because there is a law such as gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something rather than nothing. Why the universe exists and why we exist. This has been said by Stephen Hawking. So he has done enormous amount of work in black holes. He has written a brief history of time, which is, let's say, a kind of international sensation. He has written a book also, right? It is known as A Brief History of Time. A Brief History of Time. This is a book that he has written. It is very influential, very popular. Like he is let's say, like, he is a kind of observational cosmologist, right? He is considered to be observational cosmologist. He has written this book, A Brief History of Time. and he has also written the history of everything, right? So we will understand like how this book also makes sense for us, okay? So this is the thing. So once you have written, just let me know, right? Then we will start the discussion. A brief history of time, this is one thing. And second one? Yeah. This is the thing. So with this, now let us understand, okay? Now let us understand about theories, right, that talk about creation of the universe, okay? Theory of the origin of the universe, write down. So this is going to be a major heading, okay? Major heading. So it is theories of origin of universe, of origin of universe. This is going to be a very important discussion today. Okay, we are going to understand about some important things that have been less understood by, let's say, many of us so far. Okay, one of the theory that we are going to talk about, let's say the first theory that we are going to talk about is the Big Bang theory. What theory? The Big Bang theory. This is going to be one of the theory. The second theory that we will discuss shortly is known as inflation theory. What? Although inflation is a term that has been overused in Indian economy, right? We understand it a different manner. But inflation means, let's consider we have a balloon which is, let's say, without air. If we, let's say, like, blow the balloon, so it get inflated, it get bigger. That is known as inflation, okay? So this is the thing. Then third, we are going to understand about a theory which is known as quantum fluctuation theory. What? Quantum fluctuation theory. Quantum fluctuation theory. And fourth point or fourth theory, it is known as multiverse theory. Multiverse theory. Multiverse theory. And then we are going to understand a theory which is known as cyclic universe theory. What? Cyclic universe theory. Cyclic universe theory. So these are some of the theories that are prominent in, let's say, related to how the universe originated. So one of the most widely accepted theory is the Big Bang theory that we are going to understand in detail. We will understand about inflation theory, we will understand about quantum fluctuation theory, we will understand about multiverse theory, we will understand about cyclic universe theory also. However, when we talk about Big Bang theory, it has slowly and gradually encompassed all other theories in its explanation so far. Okay, so to understand how the Big Bang theory came about, so we need to understand about few people who were associated with the evolution of the Big Bang theory. So when this theory originated, this is important. Which person have given which thought process, which idea that the universe was created. So that is also an important part of discussion. Then we are going to understand in detail about the Big Bang theory. Okay. So write down the first heading, right? Write down the first heading, which is the Big Bang theory. What? Big Bang theory. So there are few people who are associated with Big Bang theory. Okay, we are going to understand about their name also. Number one, one important personality, right? His name is Georges, right? Georges Lemaitre, okay? Spelling is Lemaitre, Georges Lemaitre, right? So what he said basically related to Big Bang theory. Georges Lemaitre long back, right, in the year of 1927, when 1927. 1927 means less than a century back. So it's this theory, the Big Bang theory is not, let's say, like 2000, 3000 years back theory. It's a theory that has been postulated in 1927 itself, right, by a person whose name is Georges Lemaitre theory. But what he said, he did not coin the term Big Bang. So the term Big Bang came later, but like the idea that like something has happened came from Georges Lemaitre. What Georges Lemaitre said, he said that like long back, like if we go long back, so in the let's say like in the history of time, if we go long back, so there was a time where the entire universe as we see today, it has arisen or it has originated from a single point. What he has said, that the universe that we see, that a very long time ago the universe started just as a single point. It started and expanded till it became the universe that we know today. So he has given this idea. What idea? That the universe has started from a single point and it has expanded. So in his idea, basically you can write down this thing right quickly. So he said, number one, the universe as we see today, the universe as we see today has originated. The universe as we see today has originated from a single point, right? Over the time, or we can write down, it has expanded. Expanded means it has become larger, it got inflated, right? It has expanded, right, and formed the present universe, So this is what Georges Lemaitre said when in 1927, long back, right, he has said this. So soon after this, just after 2 years of what he said, right, so I am going to write down a name of another person. Just after 2 years of what he said came another person, very important, very influential person. His name is still very popular, Edwin Hubble. What? So Edwin Hubble. So Edwin Hubble, so he did it in 1927, he did it in 1929, let's say, okay, 1929. What Edwin Hubble said, he noticed that other galaxies are moving away from us. Do we know what do we mean by galaxy? Basically, like we are residing on a planet, this is known as planet Earth, right, and we are part of a solar system, right, and at the center of the solar system somewhere we have the sun, right, and all planets are revolving around the sun. This solar system is part of a galaxy, right, where other solar systems are also existing, and that galaxy is known as the Milky Way galaxy. But in the universe there are many such galaxies. In the universe there are many such galaxies. So the thing is, the smallest unit we can consider planet, it's part of solar system. Solar system is a part of a galaxy, and our galaxy is known as the Milky Way galaxy. In Hindi, Akash Ganga. Then there are similar many other galaxies that exist, right, presently, many other galaxies that exist. So what Edwin Hubble noticed, he noticed that other galaxies are moving away from us. So write it down so that you remember. So number one, he noticed, right, Hubble noticed that other galaxies are moving away from us. What? Moving away from us. This is an important thing. Apart from this, there is another observation. Second, the farthest galaxies, what? The farthest galaxies are moving faster than the galaxies. This is a very important statement. The farthest galaxies are moving faster than the galaxies near to us, right? So he says that all the galaxies that are there, they are moving away from us, and the galaxy which is very far, right, it is moving faster than the galaxy which is near to us. What do we mean by this? If we have to, let's say, like if we have to trace this particular thing, he said that all the galaxies are moving away. So if we trace back to it, right, if we trace back, so he also talks about a point which is known as singularity. What he talks about? He talks about a point which is known as singularity. I'll discuss about this singularity. What do we mean by this? So he said that let's consider we are as a planet located over here, right? If we talk about we are part of a galaxy, let's say this galaxy is over here. If there is a galaxy, this galaxy, let's say the other galaxy. So what this galaxy is doing? This galaxy is moving away from us. But those galaxies that are located far away from us, it is moving faster than us. It means it is moving, let's say there can be another galaxy located over here. If it is moving faster than the galaxy that is moving, they are moving away from us, means away. What do we mean by this? If we trace it back, we can trace this particular thing that these galaxies were earlier. Let's say now they are moving away, but if we go back in time, what will happen? They are moving closer if we go back in time. Closer means there will be a time when it has originated from a single point. It has originated from a single point, and that single point is known as singularity. What is the let's say what is the property of this singularity? Number one, singularity has two important properties. Number one, it has infinite density. Number one, it has infinite density. Number two, it has infinite mass. Okay, its density is infinite, it has infinite mass. So this is the thing. So Edwin Hubble has actually told that galaxies are moving away from one another. How they can move further from one another? If we have this particular shape. Shape means if let's say something is originating from a point, and if these things are going, let's say, in all directions at the same speed, let's say they are going at the same speed in all direction. It has originated from here, but the thing is slowly and gradually the distance will keep on increasing. And Edwin Hubble has given a law also related to this, that is known as Hubble's law. We will discuss about Hubble's law in detail, right? And Hubble's law becomes very, very important for us. Why? Because if you understand Hubble's law, you will understand the Big Bang theory in detail. You will understand singularity. You will understand Albert Einstein's theories. You will understand, let's say, things related to black hole. Okay, lot of things are there. So write down this thing related to Edwin Hubble, and he says that the universe is still expanding. What is happening? Number three, the universe is still expanding. The universe is still expanding, means it's still growing. It's still, let's say, getting larger and larger. This is the thing. So now we are going to understand about a very important law which is known as Hubble's law. Write this down. Okay, write this down. So this is Hubble's law. What? Hubble's law. So what Hubble has said? Hubble has given a simple equation. What this equation is, he has given this equation which is known as V equal to H naught into D. V is equal to H naught into D. So what is V, what is H naught, what is D? We are going to understand this thing, right? V is known as recessionary velocity of galaxies, of the objects that are there in the universe. This is the thing. And this H naught, right, is known as Hubble's constant. Hubble's constant. And what is the value of this Hubble's constant? This value is also very, very important, right? Hubble's constant. It is 71 kilometer per second per MPC. Its value is equivalent to 71 kilometer per second per MPC. I'll make you understand what do we mean by MPC, right? I'll make you understand what do we mean by Hubble's constant. And what is D? D is the distance of the galaxy from us. D is the distance to the galaxy. Okay, we can say D is distance to the galaxy from us. And how this distance is measured? This distance is measured in MPC. What? MPC. We are going to understand what is MPC, right? Recessionary velocity. How this is calculated? Velocity or speed, it is, let's say, distance upon time. So it is simply measured in kilometer per second. Kilometer per second. So we are going to understand this thing, what is Hubble's constants. This is a rough figure. And as the scientists are doing experiments, as they are doing research, they are refining this particular figure. Maybe like 0.0001, like up or down is happening with the time, right? This is the thing. So we are going to understand about this distance. What is MPC? MPC is a very important factor. This MPC is used for calculating the distance between astronomical objects. What are astronomical objects? Those objects that are big enough that reside in the universe, right? So MPC stands for this particular factor. It is known as mega per sec. Okay, so it is MEGA, mega PAR per SEC. Okay, mega per sec. Mega per sec. This is the actual thing, right? It is mega per sec. What is this? Mega per sec means 1 million per sec. Mega per sec is equivalent to 1 million per sec. 1 million per sec. 1 million means, what do we mean by 1 million? 10 raised to power 6. Something. Million means, let me write it down here. 1000, 1K is written as 10 raised to power 3, right? 1 million is written as 10 raised to power 6. 1 billion, I'm just writing BN, it is written as 10 raised to power 9, okay? Like that. So when we talk about 1 million per sec, it is 1 into 10 raised to power 6 per sec. And what is it is equivalent to? It is 3.26 million light years. What? This 1 million per, this is equivalent to 3.26 million light years. This is a very important figure. 3.26 million light years. 1 mega per sec is equal to 1 million per sec, which is equal to 3.26 million light years. What do we mean by light years? Light years, 1 light year is an astronomical distance. Light year is used to calculate the distance between astronomical units in general. But in this case, let's say Hubble has given a law where he has given Hubble's constant and he has measured the distance in parsec. And parsec is little different. For example, if you want to calculate length of something, we have let's say we can calculate it in meters, that it is 4 meter, 5 meter. We can calculate it into what? Feet, 4 feet, 5 feet, 10 feet, like that, right? So we do have different units like that. So when we want to measure the distance between astronomical units, generally the term that is used is light years. We are going to understand what do we mean by light year, and here parsec, megaparsec. Megaparsec means 10 raised to power 6 parsec, and which is equal to 3.26 million light years. Let us understand what do we mean by light year before we go into understanding this particular thing. It is very important that we understand it, but it is important for us to understand what do we mean by light year. What? Light year. So 1 light year is equal to the distance traveled by light, distance traveled by light in 1 year. This is the definition. This is the definition of light year. What? 1 light year is equal to the distance traveled by light in 1 year. So how do we calculate? What is the speed of light? When we talk about speed of light is denoted by C as a symbol, and C is equal to, like, it is not the exact figure, but we consider it to be roughly equal to, which is 3 into 10 raised to power 8 meter per second. 3 into 10 raised to power 8 meter per second. What do we mean by 10 raised to power 8? Means if you multiply 10 into 10 into 10, how many times? 8 times. You will come across 10 raised to power 8. So this is the distance that light travels in 1 second. How much time? This is the distance that light travels in 1 second, which is 3 into 10 raised to power 8 meter per second. And if we talk about in kilometer term, right, in kilometer term also, it is around, let's say, like, in kilometer, if you want to do, just divide this thing by 10 raised to power 3. So you will come across in kilometers. So this is in 1 second light travels this much. If I talk about, let's say, like, in 1 minute, how much light will travel? 60 into this C. 60 into C means 60 into 3 into 10 raised to power 8 meter per second. In 1 minute, it's going to, like, in 1 second it is, let's say I'm walking. In 1 second I'm covering 1 meter. In 60 seconds I'm going to cover 60 meters. So in 1 second light travels this much. In 60 seconds it is going to travel 60 into C, which is 60 into this thing. So in 1 hour, how much light is going to travel? In 1 hour we have 60 minutes, right, which is going to be 60, which is minutes, into this 60 into C, like that. So it will be 60 into 60 into 3 into 10 raised to power 8 meter per second. This is how light travels in 1 hour. If we want to calculate how much light travels in 24 hours, that will be 24. 24 means 1 day. 24 into all this thing, 60 into 60 into C, like that. You can do the further calculation, right? 24 hour means in 1 day how much light travels? How much light travels in 1 year? In 1 year, how many days do we have? 365.4 days, or we can consider 365 days for roughly. So in 365 days, how much light is going to travel? It is going to be 365 into 24 into 60 into 60 into C, like that, right? So this is the thing. So this is going to be the distance, right? Distance that the light travels. Distance that the light travels in 1 minute, 1 hour, 24 hours, 365 days. So this much distance light travels in 1 year. That is, this distance is known as 1 light year. What? This distance is known as 1 light year. Is it understood? So if we want to calculate what is the exact value of 1 light year in kilometer term, right? So this 1 light year will be equal to 299,792. 299,792 kilometer per second, I think. Okay, so you need to calculate it yourself, right? So in 1 light year, light's going to travel this much. So I mean, like, this may be little, I mean, like, so calculation you do yourself. So this is what we mean by light year, means light travels this much distance in 1 year, right? And here what we were referring to like distance between galaxies. So this is calculated in parsec term. This parsec is 3.26 million light years. 3.26 million means 3.26 into 10 raised to power 6. This, like, if we want to calculate it 3.26 million light years, so what we need to do? We need to calculate 3.26 million means 10 raised to power 6 and into 1 light year. 1 light year, you take it from the other calculation that we had. So this is the thing, this is how we calculate astronomical distances. However, we have not yet understood what do we mean by this equation. I will make you understand this thing. So what Hubble has said that the planets, right, or the galaxies are moving away from one another. All of them are moving away from one another. None of them are coming close to one another. Means the universe is expanding. And he says that a galaxy which is located far away from us, it is moving at a faster rate than the galaxy which is located close to us. Okay. This talks about singularity. So that's why it is important for us to understand this thing. So what is V? Recessionary velocity. Recessionary means the velocity, the speed at which the galaxies are moving away from us. Recession velocity, like that. It is receding from us. So the velocity at which it is receding, going away from us, this is the velocity at which. This is equal to Hubble's constant into d. D is the distance of the galaxy from us. So if we have to calculate Hubble's constant, how we calculate? We can calculate Hubble's constant by h naught will be equal to, okay, this h naught will be equal to V upon d. What? It will be equal to V upon d. V is the recessionary velocity, right, and d is the astronomical distance. Right, V is the recessionary velocity. And how do we get to know what is the recessionary velocity? For this, we do have a mechanism. That mechanism, let's say we are going to understand through Doppler effect. What? Doppler effect. So we will understand what do we mean by Doppler effect. And if you clearly understand these concepts, you will be able to solve prelims questions very easily. Mains question though, like anyhow is easy in UPSC. Okay. So let us now understand about a term which is known as, yes, which is known as Doppler effect. What? Doppler effect. After understanding this Doppler effect, right, we will finally understand about Big Bang theory. We have just started the discussion on Big Bang theory. So Big Bang theory is in itself a very big theory. To understand this, we need to understand very related things. Doppler, so write down Doppler effect. So what is Doppler effect? So write down its definition. Doppler effect is a physical phenomena. Write down. Doppler effect is a physical phenomena. Doppler effect is a physical phenomena that occurs when there is relative motion, between a source of wave and the observer, Write down full stop. This effect causes a shift. In causes a shift in the frequency of the waves. This effect causes a shift in the frequency of the waves as perceived by the observer, as perceived by the observer. As perceived by the observer. V plus V naught upon V plus Vs, V plus Vs into Fs. I am going to make you understand, don't worry about the formula that we are coming, right? Some of you may not be from science background, so may find these formulas to be little tricky to understand, but I am going to make you understand about this through simple examples, right? So now here we need to understand what is F naught. So F naught is the observer frequency of sound. Write down, it is observer frequency of sound. Observer frequency of sound, F naught. Now write down then Fs. Fs is actual frequency of sound waves. Okay, it is actual frequency of sound waves. Now write down V. What do we mean by V? V is the speed of sound waves. Speed of sound waves. Now write down V naught. This is read as naught, okay, whenever we have this small dot, V naught. V naught is observer velocity. It is observer velocity. Now write down Vs, source velocity. So what is Doppler effect? The definition that you have seen, right? To understand that definition, right, you need to understand these examples. And before we go into those examples, now you need to understand that Doppler effect is applicable for, let's say, sound waves, right? It is applicable for sound waves. It is also applicable for light waves. What? They are applicable for sound waves as well as they are applicable for light waves. So how they are applicable for sound waves? What are sound waves? Sound waves are those waves that are known as mechanical waves. They are known as longitudinal waves, right? Sound waves are longitudinal waves. And if I talk about light waves, what is the nature of the light wave? Light waves are? Dual nature. Okay. And what about you? Okay, tell me one thing. If I throw something, a stone on a pond, on a river pond, so it creates some ripples, wave, it creates, what is the name of that wave? Transverse wave, right? And how it is different from electromagnetic waves? Basically, when we talk about light waves, their nature is similar to electromagnetic waves. Sound waves need a medium to travel. Medium means sound can travel on the surface of earth because we have air molecules, we have atmosphere. Whatever I am speaking, you are able to hear, right, just by sitting near to me, right? But the thing is, if we go to moon, on the top of the moon, on the moon there is no atmosphere. And if we stand close to one another, if I speak something, you will not be able to hear because sound waves do not travel, right, in vacuum. They will not be able to travel in vacuum. They need a medium to travel. Sound waves need a medium to travel. In case of light waves, they do not need a medium to travel. They can travel without any medium also. So this Doppler effect, it is applicable for sound waves also, it is applicable for light waves also. Later on, let's say like in our discussion, maybe like after a few days, we will discuss in detail about the characteristics of sound wave, characteristics of light wave. We will let's say draw the diagram also, right, you know, to understand how the let's say waves propagate, right, and in what medium they propagate, like that. Yes, so Vidya has written light waves are transverse waves, light waves no need of medium, right. So this is the thing. So having understood this, now here the definition that you have written, there you have written that whenever there is a relative motion between an observer and source of the wave. Source of the wave means it can be source of the sound wave, it can be source of the light wave. Let's consider this thing, let's understand this part. Let's say like, you know, this is a person who is an observer. What? Who is an observer. And over here what happens? Let's consider a car is traveling towards him. What? A car is traveling towards this observer. So this car has both the things. Number one, it can make sound because it has horn like that. It can have a bulb also, it can be a source of light as well, because headlights are there on the car. So what happens when the observer is standing, the car is moving towards the let's say observer. As the car comes towards the observer, the sound that he hears is steeper, it has more pitch as compared to the sound that he hears when the car is far away. Let me give you another example. Have you ever like, you know, like have you ever gone to a railway station? So when trains are traveling towards you, when they are coming from far away towards you, the closer they are coming, the noise of the sound gets steeper. So the thing is, observed frequency of the sound wave, right, increases. So when the let's say source of the sound or source of the light moves toward you, right, the perceived frequency of the sound wave or of the light wave, right, seems to be higher as compared to the normal or actual frequency. This is what is known as Doppler effect. What are its effects? For example, what are its effects? Now let us understand its effect, right, its effects. So we are going to understand its effect in let's say like, you know, in two cases. Number one, we are going to understand its effects related to sound. Number two, we are going to understand its effect related to light, right. When the let's say like, you know, source of the sound, right, moves towards you, right, when they move towards you, I am just writing you, considering you to be an observer, right, what will happen? Pitch of the sound increases, okay, pitch of sound increases. When the train is coming towards you, you hear steeper sound, pitch of the sound increases, right. When the source of the sound, right, source, move means when the source moves, right, when the source of sound, source, right, moves away from you, what happens? Pitch of the sound reduces. I am just writing reduces, okay, because of a space thing. It reduces. In case of light, what happens in case of light? Light showcases similarly two phenomena. Number one, if the source, right, if the source moves towards, right, if the source moves towards the observer, what? Towards the observer, we see something which is known as blue shift. What? we see blue shift. When the source moves away from the observer, when the source moves away from observer, we see a kind of shift that is known as red shift. What? Blue shift and red shift. What? Blue shift and red shift. Okay. So now let us understand what is happening here. We were talking about Big Bang theory. We were talking that the universe is expanding. We know that, like, galaxies are receding from one another. Like, as has been observed by Hubble. Edwin Hubble has observed this particular thing. He said that galaxies are moving away from one another. Since galaxies are moving away from us, so there must be some shift which is known as red shift. What kind of shift we will see? We are here, Earth, right? Galaxies are moving away. So we will see a perceived change in the frequency, and that perceived change of the frequency will be in red shift. If they are moving away, red shift. If they are coming towards you, blue shift, because frequency will increase. Increased frequency showcases blue shift. I will talk about this thing when we discuss about electromagnetic radiation. There we will understand about the frequency ranges also. We will understand about X-rays, visible light, ultraviolet light, etc., microwaves, etc., right? So the thing is, as of now, what we need to understand, if, let's say in case of sound, if the, let's say the source of the sound is moving away from you, you are going to hear less pitch. If the source of the sound is moving towards you, right, you are going to hear more pitch. Right? In case of light also, if the source of the light is moving towards you, it will be blue shift because frequency will increase. If the source of the light is moving away from you, you will see red shift, means it is receding. So here what Hubble has said that the galaxies are moving away from us. So it means recessionary velocity, recessionary velocity. And let's say we can see what? We can see red shift in the universe. What? Red shift in the universe, because universe is expanding as of now. What? Universe is expanding as of now. So this is red shift, and this red shift concept comes from Doppler effect, as we discussed. Okay, it comes from Doppler effect. So having understood this, now let us understand about Big Bang theory in detail. Okay, this is very important that we understand the Big Bang theory in detail, and these are related things that we have understood so far. So let's understand about Big Bang theory. So we had discussed about two personalities so far. However, there is another personality we will discuss. Right? Another personality. So which personalities we have discussed? Can you tell me name of those people? Georges Lemaitre. What is the spelling? Lemai. TRE or TER. This is TRE. Okay, Georges Lemaitre. Then second person that we have discussed about is Edwin Hubble. So Georges Lemaitre came up with the idea that the universe started from a single point, and Edwin Hubble talked about it in detail. He has gone into scientific research. He has given a formula also. Which formula? He has given this V is equal to H naught into D, right? So what it says, like if, let's say H naught is known as proportionality constant. So if we remove H naught, so V is proportional to D. Like those people who are from science background, mathematics, who have studied little bit, they'll be able to appreciate this thing that V is proportional to D. Means if the distance between us and the galaxy is more, so the velocity of the galaxy will be more, like recessionary velocity. If they are close, the velocity will also be low, but anyhow they are moving away from us. This is the thing. Okay, Edwin Hubble. There is another personality, and this person actually has coined the term. Which term? This particular term that we know, Big Bang. Okay, I have written his name also. This is, like names are very difficult to remember of these personalities. This person is, his name is Fred Hoyle. Okay, Fred Hoyle. What he has done, Fred Hoyle, basically Fred Hoyle in 1949, okay, when in 1949, he was doing a BBC, let's say, radio, he was participating in a BBC radio broadcast, and he, Hoyle himself is an astronomer. What? Hoyle himself is an astronomer. So what Fred Hoyle has said, so basically he said that these theories, right, were based on hypothesis that all the matter in the universe was created in a Big Bang at a particular time in the remote past. So while he was, let's say, like, you know, interacting with the BBC people, he said that all these theories related to the origin of the universe, right, these theories are based on a concept. Which concept? That, like, you know, the universe was created from a small point with a Big Bang. Means, like, you know, the small point has exploded. So in his, let's say, like, you know, interaction, he has referred to this term which is known as Big Bang. What? Big Bang. He has referred to this term. So that's why we know it as Big Bang theory. However, this has originated from Georges Lemaitre. Georges Lemaitre was a priest also. He was an astronomer, and then he was a priest in a kind of church. So that's why he said this thing. Then came Edwin Hubble. Then came Fred Hoyle. So these are the people who have postulated. Now let us understand about Big Bang theory. Okay, this is going to be very important part of the discussion. Okay, so what Big Bang theory says? Big Bang theory says that the universe was created long back. How, let's say how back? 13.8 billion years ago. How much? So let's understand about this. So write down about Big Bang theory. Quickly write down this, write down about Big Bang theory. So write down, yes.
George Lemaitre was a priest, so he said that the universe originated from a single point in sense of astronomy, or priest like a god is the
No, both the things. Initially people have rejected his ideas, but later on scientists also came into it, and, like, you know, they have done their own discoveries, they have done their research. Later on many evidences have been found. Today we are going to discuss about, let's say, many evidences or many evidential, let's say, experimental evidence that talks about that Big Bang theory actually happened.
I am asking, like, he said in which context, like single point as in God and the universe
No.
from him, or like a single point like a high density mass?
No, he said from high density point of view, but since he was a priest, initially people has rejected this idea. But after 2 years, Edwin Hubble has done huge research on this, and the United States of America has launched Hubble Space Telescope. UPSC has asked in the mains exam related to Hubble Space Telescope, right? And today itself, let's say, there is an article in newspaper that talks about Hubble Space Telescope, a new discovery that has happened. Right? Why Hubble name? Because he was an American astronomer. So, like, you know, let's say, like in India, if we do something, we will be using the term name of Aryabhatta. We will be using the term of name of those people who are from Indian origin, like that. So this is the way. Okay. So now write down this, what? Big Bang theory. So write down Big Bang theory. Big Bang theory talks about the early development. Big Bang theory talks about the early development and evolution of the universe. Big Bang theory talks about early development and evolution of the universe. Early development and evolution of the universe, right? Of the universe. So what Big Bang theory has said? Number one, it has said that the universe has originated, right? Universe has originated around 13.8 billion years ago. 13.8 billion years ago. 13.8 billion years ago means 13.8 into 10 raised to power 9, right? Years ago. This is the thing. 13.8 billion years ago. This is what it says. So after this, what has happened? So it has started from a single point, and that single point is known as singularity, and that single point has infinite mass, it has infinite density. It exploded. After explosion, what happens? Within a fraction of second, it has expanded so much. It has expanded so much that it has led to the creation of subatomic particles. What are subatomic particles? For example, the proton, neutron, electron, right? So these things were formed then, but at that point of time, atoms were not existing. Atoms were not existing. Later on, let's say so as the universe has, let's say cooled down, so it has led to the formation of atoms also, right? It has led to formation of atoms. The earlier atoms that were formed, they are of hydrogen and helium atoms. Okay, that has happened. Today we are going to draw a diagram. We will talk about the shape of the universe, right? We'll talk about that how these atoms have originated. We'll talk about the plasma also. Plasma, have you heard about it? It is fourth state of matter. As of now, what we know that like solid, liquid, gases, these are the three states of matter. But plasma existed after the Big Bang. So plasma was a kind of a state of matter when these subatomic particles were, let's say suspended in plasma. So this was the fourth state of matter, plasma. And now we have these three states of matter that we are talking about, right? That we perceive, that we see. But plasma was formed after the Big Bang. We will discuss about the nature of the plasma. We will talk about the cosmic microwave background radiation, right? So there are many things. Now we came into the technical part of the discussion. So the universe originated with a Big Bang, and that Big Bang happened from a point singularity that we discussed earlier. It has originated at 13.8 billion years ago. Apart from this, so there was a cosmic inflation, okay? That is known as, this is known as second phase. This phase is known as expansion. What? The expansion phase, which is cosmic inflation. What? Cosmic inflation. For example, if you have a balloon, if you blow the balloon with air, it's going to inflate. Similarly, after the Big Bang, what has happened? The universe has expanded. And we are going to discuss, let's say how soon, what changes has come to the universe. This is going to be important. So expansion has happened. This is known as cosmic inflation, which is, let's say this cosmic inflation happened from where? Singularity, right? From singularity. Singularity means a single point with infinite mass and infinite density, right? This is the thing. After the expansion that has happened, led to the formation of matter, okay? So after this, after expansion, the third phase was formation of matter. So the matter that was formed, these matter are, let's say they were subatomic particles. What? They are subatomic particles. What particles were they? They were, let's say, electron, proton, neutron, etc. But atoms were not formed initially, and these particles were suspended, okay? After this came another phase, which is known as recombination and photon decoupling, okay? Fourth phase was recombination and photon decoupling. Now let us understand what do we mean by recombination. So basically these like after the formation of the matter, when the matter formed, so like subatomic particles were created, and these particles were suspended in a medium which is known as plasma, and plasma was the fourth state of matter. Fourth state of matter. Why we are saying it to be fourth? It should be the first state of matter. Because initially when we started learning, we understood that this is solid, this is gas, this is liquid. So to keep our normal notion, to keep our normal understanding as it is, so we have considered these are the three states of matter, and that we considered to be the fourth state of matter. However, that was the first matter that was created, where the subatomic particles like this were what? Suspended. Okay, this is the thing. So after this, what happened? Recombination happened. Recombination means the electron, proton, they started coming together, and it has led to the formation of, let's say, hydrogen. It has led to the formation of helium, like that. So these are primeval elements. These are elements that were formed long back, primary elements. So these were formed, hydrogen and helium were formed then. Okay, and what do we mean by photon decoupling? What is photon? So basically photons are energy packets of light. So the light rays that we are receiving from the sun, the lights that are traveling over here, these consist of subatomic particles. These consist of, let's say, something which is known as photon. Photons are energy packets. They have both the qualities. They showcase the quality of a matter, right? They showcase the quality of a wave also. So it follows like wave particle duality. Okay, so in science we have wave particle duality. So it follows that particular thing. So photons can be generated. If you have a light source, if you are turning on the light source, so light is generated. Photons can be generated. Photons can get destroyed also. But to get destroyed, it has to interact with some matter. It has to interact with some kind of matter. So let's consider if you have light, right? If you are lighting up the light somewhere, and if you have dark background, so after dark background, the light will get destroyed like that. So it is no longer visible. That's the thing. So this is the quality of the photon. Photons are energy packets. They are nearly massless, right? They are nearly massless. And apart from this, they do have, let's say, a lot of qualities associated with it. Okay, we are going to discuss about photons also in later part of the discussion. So photons were created, let's say photon decoupling happened. Decoupling means initially after the Big Bang happened, all the matters were concentrated in a region, like they were not able to escape from there. But after the recombination happened, after the primeval matter were formed, then photon were able to move freely. They were able to escape from that region. So that's why photon started traveling. So from after the universe was formed, right, since then those photons, those light packets that got free, right, they are still traveling. They are still traveling to us. So that's why whenever scientists, let's say, discover light waves coming from some distant planets, so using that light wave, they say this much distance that the source is located, right? Because they calculate how much time it took for the light wave to reach to us, how many light years it took. Based on that, they understand where that thing is located, how big is that thing, whether it is a source of light or not. So stars are generally sources of lights, right? Stars means what? Sun is a star, right? So in sun, this kind of thing is happening. So from black holes also, when black holes explode, so they also emit this particular thing. So from then, photons have been still traveling. They are still traveling. Okay, photons are there. Let's say if they are traveling through vacuum, they will not be destroyed. I mean they need something to destroy. Otherwise, let's say they will keep on traveling for long to happen. So today we are going to see the shape of the universe also. Have you written recombination and photon decoupling? Have you understood about recombination? So what happened in recombination? Formation of subatomic particles happened that include electron, proton, neutron, etc. I have written etc. Not only electron, proton, neutron, because what scientists are doing, scientists are still doing research. They have further come up with other subatomic particles. They are known as fermions, right? They are known as, let's say, by other names. So we are going to understand about those subatomic particles when we go into discussion of modern physics. Okay, so there will be a part of the discussion in one class. We'll discuss about modern physics. So in modern physics, we are going to discuss about all those subatomic particles, like freons, fermions, Higgs boson, very let's say many other things we are going to discuss there. Okay, so recombination and decoupling, after this thing what has happened, let's say formation of a structure has happened. Formation of a structure means formation of a structure means like slowly and gradually after the universe expanded, right, it cooled down, and like the gases that have escaped from there, so those gases slowly and gradually they cooled down, they formed, let's say, like like planets, they formed stars and all. So the current day planets that we see, they formed after the Big Bang that has happened. And I do have a diagram to show, right, to you, and that diagram, let's say, just a minute. Let us draw that diagram, okay, here to understand that thing. So that will help us to understand the shape of the universe, right. It's going to be a very technical diagram. However, if you understand that diagram, so that will be let's say, like really good for you. So what is this? This is singularity. Singularity, where the, let's say, like explosion happened. After this explosion, what has happened? I mean, okay. So this is going to be the thing. So at this point over here, Big Bang happened. Big Bang happened. When it happened? 13.8 billion years ago. 13.8 billion years ago. Big Bang happened. After then, the time period is very important for you to understand. Okay, time period. So one of the time period is 10 raised to power minus 32 second. Okay, so I'm going to write down here. Okay, over here, which is 10 raised to power minus 32 second. So at this point of time, what has happened? Inflation has happened. Oh. Let me write down. This phase over here, inflation. Write down inflation has happened over here. So within a fraction of seconds, right? So like after the Big Bang has happened, inflation happened. Inflation means the universe got expanded, right? And after inflation, at 1 microsecond, protons were formed, right? At 1 microsecond. So I'm going to write down here 1 microsecond. Microsecond means 10 raised to power minus 6 second. Okay. So here protons were formed. Protons were formed at 1 microsecond. After then, what happened? 0.1 second, nuclear fusion started. Zero point 0.01 second, right? 0.01 second, nuclear fusion is started. Nuclear fusion is started. What do we mean by nuclear fusion? Nuclear fusion means whenever we have two light nucleus coming together and let's say forming an atom. For example, let's say on the surface of the sun, nuclear fusion reaction happens. So hydrogen atoms are coming together and they are releasing huge amount of energy, and at the same time they are forming helium. So two light nuclei coming together forming one atom, that is known as nuclear fusion reaction. So nuclear fusion reaction is started at 0.01 second. So I mean like this fast the universe has expanded at that point of time. After then what has happened? So at 3 minutes, right after this, like at the point of time period of 3 minutes, so nuclear fusion has ended. Nuclear fusion ended at 3 minutes. After then, at 3,80,000 years, cosmic microwave background has been formed. I am going to draw that further part of the diagram also. Let me make it little small. There is another very important time period. I am drawing it with a different color. So this color is like it showcases cosmic microwave background radiation. What? Cosmic microwave background radiation. I mean like just this line will come to the left of this line. Okay, this is the thing. So when it has happened, 3,80,000 years ago. 3,80,000 years after the Big Bang. So when Big Bang happened, after then at these point of time, these things has happened at 3,80,000 years after the Big Bang. It is not 3,80,000 years from now, because let's say this 13.8 billion years ago the let's say Big Bang has happened. So after Big Bang 3,80,000 years ago, what has happened? Cosmic microwave background radiation has happened. What is this basically? What happens, like at this point of time, the let's say like nuclear fusion started, nuclear fusion ended, and the thing is like at this point of time what has happened, the photons were able to escape from here. Photons were able to escape, gases were able to escape, and since gases escaped from here, they left a kind of vibration over there. They left a kind of let's say radiation, like it's in the form of vibration also, it's in the form of light waves, faint wave you can see. What happens, like at night when let's say you go to the top of a building, if you see stars, let's say what happens, you see bright things means stars that are giving light, and there are places where nothing is there, but somehow some faint light is still visible. Faint light in the sense, although it is black, but something is visible which is in very faint thing. That is similar to what cosmic microwave radiation is there. Means like the photons left, gases left, but the thing is it left some cosmic microwave background radiation. So this is where let's say Stephen Hawking has worked, right? Stephen Hawking has worked in this particular area. I'll discuss, right, that particular thing. So have you understood this? After this, let's say like this neutral hydrogen has formed. Okay, neutral hydrogen has formed, and after this, from Big Bang, from here, not the other way. Okay, then after then write down this state which is neutral hydrogen formed, right? Neutral hydrogen formed. And if we go long back, means like if we go let's say further like that, universe is still expanding, and this is present day universe. Present day universe. So this is how I mean like, so 13.8 billion years ago this has happened. So if we talk about the structure of the universe, since it formed, what has happened? Since it formed, Big Bang has happened within, let's say, fraction of second, 10 raised to power minus 32 second. What has happened? It has inflated, right? After atom bomb, let's say like, after people throw atom bomb, what happens? Within a fraction of seconds, what happens? It explodes. Similarly, Big Bang has happened, okay? And after then, protons were formed at 1 microsecond, right? 0.01 second, nuclear fusion is started. Nuclear fusion ended at 3 minutes, right? And after then, cosmic microwave radiation has been formed because, let's say like, protons were able to escape. And that has happened in 3,80,000 years ago. And this time period is important because after this, like gases started escaping. And those gases, like as they went further, right, as they went further, so they somehow cooled down. And after cooling down, as we know that all objects that has masses, these objects, let's say, has gravity also. So all objects attract one another. So those gases coalesced also, they came together. They formed planets, they formed stars. So this is how we have present a universe, which was formed 13.8 billion years ago. So presently, if we see the shape of the universe, it is like this. Okay, so the thing is like, those planets, let's say that, let's say we are here, we may be here, we may be here, and those planets that are here, so they are actually moving away from one another. The planet that is over here, it is moving faster. So that's why Edwin Hubble has said, what Hubble has said, Hubble has given a law. V is equal to h naught into d. Edwin Hubble has said that V is equal to h naught into d. And this is considered to be fundamental law in observational cosmology. For example, let's say like, when we study 10th standard science book, 11th standard science book, we learn about theories of gravity. We learn about G equal to, let's say like, force is equal to G m1 m2 upon r square, like that. Similarly, this law is considered to be the fundamental law in observational cosmology. Okay, this is a very fundamental law. So it talks about that V is proportional to D, means the galaxy which is far away from us, it will be having more speed as compared to this. And what kind of shift we will see? We will see redshift, because the perceived frequency, right, of the object which is moving away, right, will be less as compared to the actual frequency, right? And this is known as redshift phenomena, right? So have we understood about this Big Bang theory so far? So Big Bang theory is considered to be the one of the fundamental, let's say, laws, like one of the fundamental thing when it comes to physics and all. So this is the thing. So having understood the Big Bang theory, now let us go back to the discussion, right, of other theories that were there. And here, let's say, initially I talked about there are few other theories. What are those theories? Inflation theory. Yes? Yes, go back to that page where you have written the name of those theories. Okay. Inflation theory. So inflation theory generally, like, it's, that theory is not backed by much scientific background, but they say that after Big Bang happened, the universe has inflated and it is still inflating. So the thing is, if you see this diagram can be reversed also, reversed in the sense, let's say like, like if you search similar topics on the internet, you will come across different kind of diagrams. One diagram will be this, in this manner. Let's say like it starts from here. You will see diagram in this manner, right? You will see, like if you see black holes also, in case of, let's say like, black hole also, you will come across diagram in this manner. So it talks about that, like, this is the singularity and this is how it is expanding. Okay, you will come across diagrams like this. So generally what is happening, the universe is in expansionary mode now. Universe is expanding, okay? So planets are moving away from one another. They are moving farther than one another. So the inflation theory talks about that since the formation of the universe, right, the planets are moving away from one another. Planet means like, galaxies are moving away from one another. This is the thing. This is simple inflation theory. Apart from this, there is a theory which is known as quantum fluctuation theory. To understand the quantum fluctuation, we need to come back to this diagram again. So let's discuss about quantum fluctuation. So when the quantum fluctuation has happened, quantum fluctuation has happened here. Quantum fluctuation, right? Quantum fluctuation. What has happened in quantum fluctuation basically? At this point of time, basically, soon after the Big Bang, within fraction of second, right? So the thing is, subatomic particles, they have vibrated at a very fast pace. They have vibrated. You are understanding? That is known as quantum fluctuation. Fluctuation at the quantum level, fluctuation at the subatomic level. So subatomic particles, when they were formed, subatomic particles, 1 microsecond. Subatomic particles, what are like protons, neutrons, electrons that we see. Before that, like, there were quantum fluctuations. So quantum fluctuations theory says that when the universe was formed, quantum fluctuations happened, and still quantum fluctuations are happening. Still quantum fluctuations are happening. Those gases that were able to escape from here, they went ahead and they formed planets, stars, and the objects that is part of visible universe to us. And those objects that were trapped, right, that are here itself. So they are still vibrating at the quantum level. Quantum fluctuations are happening. So that's why researchers are still doing research. Researchers are still trying to understand what are different types of subatomic particles. Right? What are different types of subatomic particles? So they learn about, let's say, fermions, leptons, let's say, like, Higgs boson, right? Freons. We'll discuss about all of it, right? So they are very let's say, little bit difficult. But before that, we need to understand about nature of atom, what are subatomic particles, those things. So we will discuss about that. So have you understood quantum fluctuation? Quantum fluctuation means at the quantum level, at the subatomic level, fluctuations happen and it is still happening. This is what. Apart from this, people talk about another theory, which is multiverse theory. What theory?
Quantum fluctuation led the production of subatomic particles.
Quantum fluctuations led to production of subatomic particles that led to production of, like similar things that we have discussed, okay. So those were other theories, but those theories were not having sufficient explanation. So that's why those theories got rejected. But like, somehow the Big Bang theory has encapsulated all other theories within it. Okay, this is. At parallel times it has happened, okay. At parallel times it has happened. So this is the widely accepted theory at this point of time that we have. Apart from this, people talk about multiverse theory. What do we mean by multiverse? Multiverse means, like, as of now we discussed about how the universe was formed. So universe is considered to be one where planets, galaxies, everything is there. But when we talk about multiverse, multiverse means similar universes are there which are coexisting in parallel with one another. That is known as multiverse. Means, as of now we discussed how the universe was formed. One universe, uni means one verse, right? Multiverse means multiverse, means like, many universes. So they say all of them coexist together. That was the thing. Apart from this, there is another theory which is known as cyclic universe theory. What? Cyclic universe theory. We discussed, you might have written name of it also, right? Cyclic universe theory, it says that universe is created. What? Universe is created with the Big Bang. But the thing is, after, let's say, like, after some period of time, period means like, after some sufficient big period of time, they get destroyed also. So universe is created, it gets destroyed, again it gets created, again it gets destroyed. So that is known as cyclical universe theory. What? It is known as cyclical universe theory. So these are different theories that are there, but which theory is, let's say, like, can be seen now? The Big Bang theory. Means it talks about how it originated, from where it originated, where we have reached, what is happening now. Means redshift is happening, planets, let's say galaxies are moving away from one another. This is the thing. Okay. So is it understood? Okay, we do have different theories. Apart from this, since you have written this, let us practice some previous year questions based on similar topics. Okay, there will be some previous year questions.
Cyclic theory, it's about like everything will end to a singularity and then restart, or that the cyclic nature of Earth is everyone will die and like.
Not about Earth, it talks about the universe, that like universe has started from a big bang, means like it has started from a single point, it has expanded, then it's going to, let's say, like die also to a single point, then it will start again, like that. So it says cyclic universe theory. Okay, cyclic means in circular form. People say it multiverse format also. So these are the things that are available. Now we are going to solve some previous year question. Okay, so we are going to look into the previous year question also, then we will understand about some other things. For example, yes.
Scientific backing to the multiverse theory.
Maybe, like we have not looked much into it. Why? Because whichever is the most accepted, we are understanding that thing in detail, so that like you don't have any confusion related to the most accepted theory. This is the theory which is prevalent, this is the theory which is accepted. Other theories we have just discussed with you, so that like you have some understanding that this is not the only theory which is available. Initially I talked about a story. I talked a story of Leo Tolstoy. We discussed like the coffee house at Surat, right? There we discussed that like people are there who follow different religion and they conceive the idea of God differently. They think that the universe was created differently, right? And this is the version of scientists, right? And they do have some facts also to put forward, right, in front of us. So this is one of the theory that we have understood today. So having understood this, we are going to solve some previous year question. Okay, we are going to solve some previous year question from science and technology. So let me. Huh? What I am going to do is, like, first of all I am going to take a discussion, and then let's say on the basis of the discussion I will get to know how much I have covered. Next day I am going to give you the notes of today's lecture. Although let's say you have understood through the discussion, you have written also, but I am going to give in printed format. Okay. PYQs will be included there, codes will be included, whatever we discuss that will be included, images will be included. Current affairs, so we are going to discuss in the classroom itself. Okay, don't worry. Yes. हाँ मतलब like if you have queries, you can definitely ask. Yes, आपका कुछ पूछना है? आपका? We are going to discuss here itself. In the classroom, we are going to completely cover science and technology, and every topic we are going to discuss in detail. And while discussing one topic, we are going to touch upon different areas. And I am going to make you understand all those areas in a manner so that like you have comprehensive understanding. Right? Yes, that's what I am doing as of now. Write down a question. Write down a question. Okay. So basically, let's say that day, if you have attended my class last time when we had a demo class, that day we discussed about Einstein's theory of relativity. I may have discussed about gravitational waves also. Gravitational waves means when what happens, two big black holes collide with one another, right? If let's say one black hole is there, other black hole is there, when they collide. Why do they collide? Basically, black holes are the objects that have very high density, that have very high mass. When they have very high density and high mass, what is the thing? They are able to attract the objects that are near to them. What? They are able to attract the objects that are near to them. And even if light waves pass through it, it also cannot escape because it has very high gravitational pull. Okay, we discussed about this. So gravitational waves have been, let's say, postulated, like Albert Einstein has said long back in his general theory of relativity that gravitational waves exist. He said when black holes merge, right, it leads to generation of let's say ripples in the space-time. What? Ripples in the space-time fabric that leads to the generation of black holes. and how, that leads to the generation of gravitational waves. And how gravitational waves were detected? How do we get to know that gravitational waves exist? No. Gravitational waves. I am talking about gravitational waves are different. Gravity is different. Gravity means we know what is gravity. Every object attracts every other object with a force which is equal to F is equal to G m1 into m2 upon r square. This is what we know, this is gravity. But when we discuss about Albert Einstein's theory of relativity, so Albert Einstein has talked about theory of relativity. We will start the discussion once again, but before that we want to solve some questions, previous year simple questions, okay. So then you will understand the niche, how gravitational field, let's say, come into being, why they exist, okay. It is because of ripples in the space-time, let's say space-time fabric. We'll discuss about these things. Write down a question, okay, write down a question. Which one of the following, okay, write down a question. I'm just going to write down this question for you, okay. Which one of the following is a reason why astronomical distances are measured in light years? Okay, so Vidya has written so many things. I, let's say, like, did not look into this. Light wave need no medium, that we discussed. Is this related with dying of stars after exhaustion of energy and get merged in black hole? This is related to that, definitely. Telescope detection, telescope also detect this thing. So we will discuss about a space-based telescope also, right? So you are writing a question which is, which one of the following is a reason why astronomical distances are measured in light years? Why astronomical distances are measured in light years? Write down 4 options, right? Write down 4 options. First option, distances among stellar bodies do not change. Distances among stellar bodies do not change. First option. Second option, gravity of stellar bodies does not change. Gravity of stellar bodies does not change. Third option, light always travels in a straight line. Light always travels in a straight line. Means C was that option. D option, write down. Speed of light is always same. Speed of light is always same. This is option D. This question was asked by UPSC in 2021. Okay, this is PYQ of 2021. So the first option was distances among stellar bodies does not change. Distances among stellar bodies. Reason out. Have you read this question? Reason out. Give me the answer. Gravity of stellar bodies does not change. Third option, C, was light always travels in a straight line. Statement of the question was very simple. Which one of the following is the reason why astronomical distances are measured in light years? Have you written this question, all of you? Discussion भी कर लिया आपस में? Tell me, what should be the answer? Huh? D. How many of you are standing with D? Yes. Give me a reason. हाँ? देखो सबसे पहले like let us see why other options are not correct. It says distances among stellar bodies does not change. But the thing is, this is wrong. Why? Because we have just understood that the universe is expanding, right? Universe is expanding. So that's why first option is wrong. Second, gravity of stellar bodies does not change. Gravity is a function of mass of a body. When we talk about stellar bodies, for example, if I talk about the sun, what is happening on sun? Reactions are happening. What reactions? Nuclear fusion reaction is happening. So because of nuclear fusion reaction, like atoms are coming together, they are releasing huge amount of energy. Since they are releasing huge amount of energy, so energy is generating because of mass is getting converted into energy. E is equal to mc square. So mass is reducing, energy is getting generated. After some time, the stars will get exhausted, right? I mean, all their, let's say, all the reactions will have happened, and then the stars will collapse. And when the stars collapse, they lead to the formation of black holes. You might have heard about neutron stars. That happens when massive stars, big size stars, which is of the size of thousands times or million times that of the sun, when they collapse because they run out of energy, right? So they lead to the formation of black holes. So the thing is, gravity of stellar bodies does change because gravity is a function of mass, and mass can be converted into energy like that. So that's why this is wrong. Light always travels in a straight line. We used to understand this thing up to 10th standard in our schooling, where when we understood about ray theory of light. Ray theory means when we studied about reflection, refraction like that. But later on in 12th standard, when we read NCRTs, we read about, let's say, Huygens principle, right? Wavefront theory. So, lights are, let's say, considered to be the sources of primary wavefront. It leads to the generation of further wavefronts. So, light travel, let's say, in all directions. Okay, they do not travel in a straight line. So that's why this is also wrong. And speed of light is always same. This has been said by so many scientists.
According to first option, the distance between sun, moon and us are changing. But we don't study what's the rate, etc.
We do, see, distance between sun and us are changing, sun and earth. It is regularly changing. Okay, but the change is very small. I mean, during our lifetime, it may not have changed that much that we see visible changes. But when I'm going to discuss about Einstein's general theory of relativity, I'm going to talk about that why we keep on shifting or let's say adjusting the atomic clocks that are there on the satellites, because satellites are moving around Earth, right? So the thing is we keep on shifting because with the speed, right? Time dilation happens, length contraction happens. We will discuss about that part.
And the fourth option is the speed of light is same in a medium now, but not all, because refraction happens because of change in speed of light.
It says the speed of light is always same. So we are talking about vacuum. So generally light travels in vacuum. So when it is going through a medium, when let's say refraction happens, so the speed of light in that medium changes. But the natural quality of light is that okay, yeah, that might have been there. Okay, so this is the thing. So speed of light is always same. D is the right answer in this case. So this was asked by UPSC in 2021. We will solve another question. But I don't know how much you remember from the last discussion. It's related to the last discussion that we had. So quickly you need to write another question. Okay. Shall we do another topic before we solve this question? Kitna? We have only 20 minutes. We will solve we will do another topic quickly. Okay, write down. We'll do another topic, and this topic is very much related, right? This topic is very much related to the topic that we have discussed just now. Write down the topic theory of relativity. Theory of relativity. Okay, so basically Albert Einstein has come up with two theories of relativity. What? Two theories of relativity. One theory of relativity is known as special theory of relativity. He has come up with this theory in 1905. Then after 10 years in 1915, he came up with general theory of relativity. We will discuss about both the theories of relativity. In last class, we discussed about a special theory of relativity. And based on that discussion, there are at least 3-4 questions in the prelims exam, right, from Albert Einstein's thing. So, name of the topic heading will be theory of relativity. Theory of relativity. So, who has given these theory of relativity? Albert Einstein has given theory of relativity. Write down the first theory of relativity. What happened? Anything discussing? Okay. Number 1 is known as special theory of relativity. Special theory of relativity. Write down about it. Then I am going to explain. The special theory of relativity is a scientific theory. Is a scientific theory. Is a scientific theory proposed by Albert Einstein. Proposed by Albert Einstein in 1905. In 1905. It is based on two postulates. It is based on two postulates, right? Number 1, the first postulate. Write down first postulate. The laws of physics are same. The laws of physics are same for all inertial reference frames. The laws, Yes. We are going to quickly discuss. The laws of physics are same for all inertial reference frames. Second, okay, reference frames. The laws of physics are same for all inertial frames of reference. Second, the speed of light in a vacuum is constant. The speed of light in a vacuum is constant and is independent of the motion of the observer or the source of light. The speed of light in a vacuum is constant and is independent of the movement of the observer or the source of light. Okay. So, have you written both these things? Now, what is the first postulate that talks about? That laws of physics are same. Laws of physics are same for all inertial frames of reference. What? It is talking about inertial frames of reference. What do we mean by inertial frames of reference? Inertial frames of reference are those frames of reference where the observer and the source, right, either they are at constant place, I mean like they are at rest, or one of them is moving in a constant speed or velocity, or both of them are moving in constant speed or velocity with respect to one another. Okay, they are considered to be inertial frames of reference. Okay, so frames of reference means, let's consider there is a person like this, there is another person like this. So the thing is relative to one another. When we see both of them in one frame, it can be the other person, it can be a train with a person, it can be a car with a person like this. If one of them is constant, other is moving, or both of them are moving relative to one another, either they are at rest or they are moving with uniform speed or velocity. That will be considered to be inertial frames of reference. And what do we mean by laws of physics? So when he talks about laws of physics, he refers to the classical laws of physics. Classical laws of physics include lot of laws. Some of these laws, as we know, for example, the laws that were postulated by Newton or Newtonian laws. These are known as classical theory of physics, right? He talked about, let's say, 3 laws. What are those 3 laws of Newton? Anyone who can remember? Right. So number 1, the first law of given by Newton is law of inertia. It is a body continues to remain in its state of rest or in a state of motion unless and until it is, let's say, acted upon or compelled by some external force. Means like if you are at rest, you will continue to remain in the state of rest unless you are disturbed. If you are in a uniform motion, you will keep on moving uniformly in that direction, right? You will keep on moving uniformly, right? Unless and until someone stops or someone pushes, like applies some force. And when we talked about that, this thing, what? Big Bang theory. After the expansion, the universe is expanding. All the planets, I mean like everything is moving, right? They are moving in the same speed, but they are moving in different directions. This is the thing. So that's why, let's say like, relatively, the speed between them, the distance between them is constantly changing. This is the thing. So that was first law, Newtonian law, law of inertia. Second law, what is the second law? Yeah, force is equal to rate of change of momentum. So basically second law in simple words, if I talk about that, like, if you want to, let's say like, change the state of a body, you need to apply some forces, right? And the force that you apply will be equivalent to, let's say, will be equivalent to many things, which is, let's say, mass into acceleration. Means like even a smaller body can have bigger impact. For example, bullet, right? It can have bigger impact on the object. And big bodies can have lesser impact also if it goes with less speed. So there is role of speed, there is role of mass as well. Speed means like, like acceleration basically in that thing. Force is equal to mass into acceleration, that's the thing. Okay. Third law is known as law of action and reaction. Law of action and reaction. What is law of action and reaction? Simply like it says, to every action there is an equal and opposite reaction. Means if you are making an action to something, so there will be an equal and opposite reaction to it. Means like, if you push on the wall, so you will also get hurt. It's not the thing that only the wall will happen. So this is the thing. So this is laws of physics. So they will be applicable in all inertial frames of reference. They will remain the same in all inertial frames of reference. But when we talk about singularity, the Big Bang, so beyond singularity, let's say like, laws of physics do not apply there. We'll discuss about that thing. So laws of physics are same for all inertial frames of reference. What was the second thing? Second thing is the speed of light in a vacuum is constant, right? So Albert Einstein has postulated this thing in 1905, and the answer that we have given to the question, speed of light is always the same in vacuum. So this is what is postulated by Albert Einstein. So this was asked by UPSC in 2021. However, let's say like, on the basis of this special theory of relativity, we can see various counterintuitive effects. What counterintuitive effects? Last time we discussed that time dilation happens, length contraction happens. What do we mean by time dilation? I discussed about twin paradox. What? That time I discussed about twin paradox. Two brothers who are twin to one another, one of the brother remains on earth, the other brother goes on a spacecraft, he goes up very high speed. So a person who is, let's say, moving like with high speed, so for him time appears to let's say like pass slowly as compared to a person who is at rest. So this is the thing that is known as time dilation. And we have seen impact of time dilation also. What is the impact of time dilation? For example, we have the satellites that are revolving around the earth, and in those satellites we do have atomic clocks, and those satellites, since they are placed very near to the earth in the low earth orbit, so their speed of revolution around the earth, they are revolving around the earth, their speed of revolution around the earth is faster than the rotation speed of the earth. So that's why they see time dilation. What? That's why the, let's say like satellites see time dilation, and that's why, let's say like we keep on changing the, let's say like adjusting the time atomic clock of the satellite. So that was impact of what? Time dilation. Time dilation, you understood? We discussed. All you need to do is you need to go back to the previous discussion to understand that thing. Second thing, we discussed about length contraction. What was length contraction?
Particle will appear shorter. The particle which is moving will appear shorter to the observer.
Right. So an object which is moving will appear shorter to the observer than an object which is at rest. So there also we discussed about which, like we discussed about Doppler effect, right? We discussed about Doppler effect there also, because the wavelength, right? Wavelength, what happens? The perceived wavelength of the object changes. If the object is coming nearer to you, the perceived wavelength will appear to be shorter, right? So the object will appear to be shorter, that's the thing. If the object is at rest, so wavelength, let's say like will be high, like that. So this is the thing. So we discussed about length contraction, we discussed about time dilation, and these are part of, these things are related to Albert Einstein's special theory of relativity. However, Albert Einstein has also talked about mass energy equivalence. What? So let's say it does have some counterintuitive effects. I'm going to give, let's say, notes of these two things tomorrow, let's say like of today's lecture and the previous lecture that we had in one compiled format, that will be class 1. So you will be having in printed format. So what were the effects? Number one effect was time dilation. What was the second thing is length contraction. What was the third thing? Mass energy equivalence. Time dilation, let's say we to understand this we have talked about twin paradox, right? We have talked about twin paradox. Length contraction, related to this we have talked about atomic clocks on satellite. Time dilation, we talked about twin paradox, and we have seen atomic clocks as examples of it. Length contraction, we have seen, let's say, size of moving objects, right? Size of moving objects. And when we talk about mass energy equivalent, I have said E equal to m into c square. So mass can be converted, small mass can be converted into huge amount of energy, and we have seen this particular thing in, let's say, the atom bomb that were, let's say, thrown in Hiroshima and Nagasaki. So in Hiroshima and Nagasaki, atom bombs have been thrown. So a smaller amount of mass is able to create large amount of impact. It's able to release huge amount of energy. That has happened. And also when we talk about power plants, we have nuclear power plants, right? The nuclear power plants that are located in India and across the world, what happens? There we convert mass into energy. There we have nuclear fission reaction. FISSION, nuclear fission reaction. We are going to understand about the difference between nuclear fusion reaction and fission reaction. But in power plants, nuclear fission reaction happens. So their mass is getting converted into energy format. So Albert Einstein has said that mass can be converted into energy, and that has led to the development of atomic bombs and all of it, right? Manhattan Project. We discussed about Manhattan Project last time. What was the name of the scientist? Robert Oppenheimer. We discussed about this, right? So this is the thing. So these were the counterintuitive effects of let's say like a spatial theory of relativity, right? Now we are going to talk about general theory of relativity, okay, which is going to be very important. So we are going to cover general theory of relativity, and we are going to cover some important questions also, okay, today itself. So this is the second thing. General theory of relativity. So let's discuss about general theory of relativity. Write down about it. The general theory of relativity, is a scientific theory, proposed by the general theory of relativity is a scientific theory proposed by Albert Einstein in 1915. Okay. Full stop. It is a theory of gravity. It is a theory of gravity that describes the behavior of massive objects. It is a theory of relativity. It is a theory of gravity that describes the behavior of massive objects and their interaction with the geometry of space-time, Describe behavior of massive objects and their interaction with geometry of space-time. Okay. So now let us understand this particular part. Okay, write it down. Write down then next paragraph. The key concept in general theory of relativity, the key concept on general theory of relativity, is the idea that gravity is not a force, that acts between two massive objects, but rather a curvature of space and time, caused by the presence of massive objects. Write down. The general theory of relativity, next line, next paragraph. The general theory of relativity predicts several phenomena that have been observed and confirmed through experiments. Number 1, write down gravitational time dilation. Number 2, write down gravitational lensing. Number 3, Write down gravitational waves. Gravitational waves. Gravitational time dilation, gravitational lensing, gravitational waves. These are the three counterintuitive effects of gravitational thing. So it does have application in various areas. Okay, so I'm going to write down these things short, right? So these are counterintuitive. I'm just writing effects, right? Effects, which can be explained through this general theory of relativity. And if I talk about applications of general theory of relativity, applications number 1, okay, where we apply this general theory of relativity, number 1, GPS technology, okay, GPS technology. Number 2, write down cosmology and fundamental physics. Cosmology. Fundamental physics. So these are the areas where they are applicable. All right. So we will discuss in detail about the general theory of relativity tomorrow. We'll solve some questions also, and tomorrow I'll give you the printed notes of today's class and of the demo class that we had. Usme your attention will get divided. You understanding? You will focus on the notes, not on the teacher. That's the thing. So this is the thing. Okay. So like after we cover whatever portion we have covered, I'll give you note. That will be more effective. वो ठीक है. It's like लिखा हुआ ये short format है. You will remember it. Notes will be for revising purposes. After going home, you can revise it from here, that way. Okay, so this is the thing. So, Shivji Singh, thank you so much. Good evening, Shivji. So that will be all from my side for today. We'll discuss further things tomorrow. Okay, yes.